worldwide solar and energy storage podcast at Intersolar San Diego. Stay classy, San Diego. Whoa, whoa.
All right, we're here at Intersolar. We're staying classy, San Diego, and we're with Michael Wise, and Michael Wise is the Commercial Operations Manager of LS Energy Solutions. So Michael Wise, why are you so wise?
I don't know why I'm so wise. I'm good company, I think.
Oh, that's a really good answer. I like that one. So LS Energy Solutions, I guess you're making inverters, right?
Yes, we do.
Mm-hmm.
So we make the Power Brick, which is a 140 kilowatt string inverter, air-cooled for grid scale energy storage market. And we also make the MSSP Gen 2, which is the new liquid cooled version that's going to be rolling out in the years to come.
So you said for 140 kilowatt for energy storage.
Yes.
So are you doing PP inverters too, or just keeping it with energy storage?
So we typically are on this side of the DC combiner. So we do work with solar companies, but our scope generally stops at the inverter terminals.
Okay. And so you have an inverter. And so what kind of jobs are your inverters usually used with? Would it be like behind the meter, I guess, probably?
Yes. So a variety of different behind the meter applications, energy arbitrage, frequency regulation, asynchronous generation support, lots of different applications. Our Power Brick is a very well developed model, and it's got a lot of different capabilities. And these capabilities we also want to reflect in our new iteration of MSSP Gen 2. Got a ton of experience back when our company was Parker Hannafin. We did the first grid scale lithium ion energy storage system. And so we're just continuing now and today in 2026 and expanding our borders and our capabilities and, producing more and more energy storage projects and site level, projects that we can be proud of with our customers.
Okay. So you're making the inverter. What's your relationship with like battery companies? Does your inverter company just work with anybody that knows how to like put some lithium in a blender?
So since we make the inverter, it requires a DC power source, as do all inverters. So that means we're kind of battery agnostic, which means we can apply a variety of different DC solutions to our inverter terminals. Not only can we do the inverter as an all-in-one integrated system, but we can also supply the inverter as a central string where the DC solution is external to the power conversion system. So we've got a variety of different ways we can integrate those inverters and they can work on a grid scale.
So where do you see the systems being used? What does it look like? In a container, or so you're having like container types of energy storage systems? So what is it, 8 feet wide, 8.5 feet tall, 20, 40, or 53 feet long?
So we have our own bespoke design. It's called the Ion, all-in-one ESS energy storage system. It has both batteries and inverters and balancer system all inside of one 20.
So you make the whole energy storage system?
Yes, that's our Ion ESS. But again, we have our central inverter, which is just an aggregation of inverters inside of a box that we combine with different DC solutions like Samsung, LG, what have you, up to 1500 volts. So we're very flexible in how we can apply our inverters to the market and also what DC solutions we can work with.
So it's sort of like the inverters, they're not like huge multi-megawatt inverters, but then you put a bunch of them together and you get your multi-megawatts.
So we make a string inverter, which means that it's scalable. So 140 kilowatts scales up to whatever power level you would like. We've actually scaled up to 200 megawatts, greater than 200 megawatts at one of our most recent projects called Big Rock. It's 200 megawatts, 400 megawatt hours in Imperial County, California. The benefit of the string inverter is that if you have a problem with an inverter or a part of an inverter system, you don't lose all of your inverter power. You only lose that block that's affected, and the rest of the inverter system continues to run as normal. And so you have a large uptick in availability using a string inverter versus a large central inverter. And so many of our customers, they see through that as an opportunity to make more money in diverse and challenging atmospheres in the field.
So let's kind of talk about how things are configured. Like when you call it a string inverter, I usually think of like string inverters being like solar, and you put solar PV modules in series and you have a string and you might have like 10, 20 or 30 in series, something like that. And that would be like your string inverter where you plug all those modules into an inverter. And if it was like a multi-megawatt inverter, you would parallel them together first before you brought them to the inverter. So that would be called a central inverter.
Yep.
And how does that work with batteries? Are you following a series connection still, like with solar, or is it a parallel?
So it's still a parallel connection. So we'll aggregate that power into a common AC bus. And so same again from the DC bus, which is how we're able to make our inverters work. But in any case, as long as there's no problem on the AC bus, our inverters function autonomously. There's not going to be, as long as the master functions, the slaves can function as well, or the master can also be changed on the fly. So again, there's just a large opportunity to keep the inverter system running in case there is a problem in the field. And that's the way we actually aggregate them.
When you call it a string inverter, so you have like, let's just talk about like one of these 140 kilowatt inverters.
Yes.
And then you have like a bunch of batteries. Mm-hmm. And how are the batteries connected to the string inverter? Or like, so each one of them is a different string inverter. And so you're going to have like series and parallel connections, I guess, go in?
So it's going to be parallel. So if you think about the all-in-one is going to have a number of battery racks. It's going to come through.
So these battery racks or modules in the racks and stuff like that.
Aggregate to the DC bus, and then the inverters will feed from the DC bus through their fusing, and then aggregate to a common AC bus to the container output terminals. Now, central string looks a little different, but it's generally the same, except that the DC comes into the central string and then goes out to the customer's AC bus, which is typically going to be, owned and managed by the customer.
So you have like a rack, and I've seen some of these, like, these racks. It kind of reminds me of a musician, and they have like all their amps in a rack, and so it's like kind of like that, like rock and roll. You like rock and roll?
I love it. Yes.
And so they put all these things in the rack, and they see them do it with like servers, and they do it with batteries and all that kind of stuff. And so inside there's that battery module, and there's going to be battery cells that are connected together in series inside of that module, and it gets it up to a certain voltage, and then these modules then are connected to your inverter in parallel.
Yes.
Okay. And they're calling that a string.
Yeah.
Okay. And then on the output, then you're going to have alternating current coming out. And so what voltage AC is coming out?
So we can do 400 to 690 volts, depending on the inverter and configuration, and also the customer's preference.
So it's not like some kind of American grid voltage that's coming out. And with alternating current, is it three-phase?
Yes, definitely three-phase. It depends on the customer's transformer and how it's set up. So, that'll be specified before the project ever starts. So again, our inverters come in 400, 480, 600, and 690 volt AC.
Okay, great. And so then you do have like the 480, so that would be some kind of like common grid voltage for commercial buildings and things like that. And 600, Canadians use that instead of 480. So do you like Canadians or hate them?
No, we love Canadians.
Okay, me too, yeah. Especially during the Winter Olympic times. But then there's like the 400 volts, and that's more like European and Asian and stuff like that. So is that like, are you kind of keeping it at the local grid voltage?
It's mainly for flexibility. So different customers will have different requirements. And so we like to be able to service, all of our customers' needs based on our existing product portfolio. So we do have the capability to offer that 400. It's not as demanded now as maybe before, but now it's more 480s and 600s, but we do have that capability.
Okay. And do you see like, is it regional? So like 400 is pretty like Eurasia or, like most of the world. Yeah, Eurasia, Africa, all that stuff. And then you've got like 480 North America, except for Canada, 600. You don't see it like doing what we would have on the grid, but they're not matching the grid voltage.
So we do utility scale energy storage, and we've also come from a background of commercial and industrial energy storage devices. So typically those will be building level energy storage devices operating at around 480 volts or so. And that's what that power brick, that 480 power brick is for, for that commercial and industrial system.
Great. How big are the systems that you're working with? So you're working with a manufacturer, and then you're like selling it to somebody who's like EPC integrator type of person.
So our project size is anywhere from 5 megawatts, 15 megawatt hours for a grid scale on up to 200 megawatts, 400 megawatt hours out at Big Rock in Imperial County, California.
And did you get to go see that one?
So I'd encourage anybody that has the ability to go see that. It's technical marvel.
Will they let me in there?
I don't know if they'll let you in, but you can take pictures from outside the fence.
Yeah. And so with that system, I know you said sometimes you'll have like a container full of inverters and another container full of batteries. Sometimes they're in the same container.
So Big Rock is an all-in-one that has batteries and inverters inside the same 40-foot container. So that's a bespoke system for Big Rock. So it's an all-in-one, but it's just a larger form factor than what we've made before.
And then with that, do you access the batteries Like, can you go inside the container, or is everything from the outside? Yeah.
Yeah, so it's not habitable. There's no space inside for people. It's literally packed to the gills with batteries, inverters, fans, balancer system, and things like that. But everything's accessible from the outside, from the way the doors are configured.
Yeah.
And the technicians will typically just come up to the outside of the container and do their work.
Yeah, and I think a lot of that comes back from like one of the earlier containerized energy storage systems in Arizona.
Mm-hmm.
They could go inside of it, and it was smoking, and somebody went inside, and it was a really bad idea. And so if you cannot access it from the inside, that's a really good idea. And then if there's any problem, they're all these different units, and they're a certain distance away from each other.
That
Do you
is
know
correct.
how far apart from each other? Are they like 10 feet?
10 feet is standard, and some customers can space them a little closer depending on what support we have from the battery manufacturer. I know that Samsung with the SBB, the Samsung battery box 1.5 and 1.7, they do have some constrained space alternatives for customers that have a need to fit more battery into a smaller space.
Yeah, and usually you don't need that much. It's like one of the things about solar is you have to have it kind of spread out because you're catching sun rays. But with batteries, you can layer them on top of each other.
Yeah, you want them as dense as possible.
Yeah. And so you're keeping these things apart from each other in case something goes wrong with one, all the other ones are going to be fine.
Yes, that is correct. Yes.
Create any kind of like chain reaction or something that we don't like to see.
That's the goal there. But keep in mind that where a utility scale energy storage system is sited, it's generally going to be right up close to the distribution system. And that land isn't going to be cheap. And so, when our customers look at how they're going to deploy these energy storage systems, that's a very big factor. And, how much storage and how much power can they get out of the system within the space that's required. And it wouldn't seem like it'd be that big of a deal, but it really is.
Mm-hmm. Yep.
We interrupt you for a very important announcement. Sean White's Solar and Energy Storage Podcast has been brought to you by Sean White's Solar and Energy Storage Podcast. That's right, Sean White is sponsoring his own podcast, and he wants to remind you to go check out some of his classes. You can go to SolarSEAN, that's Solar, SEAN.com, and then click on the links to check out his classes. You can check out his heat spring classes, and you can also hire him to teach classes for you, like at your company, something like that. Now back to the show.
And do you see any other types of energy storage that you're working with? I know like lithium ion batteries are what everybody's using, lithium iron phosphate almost always. Are you seeing other stuff like with what you're working with?
Yeah, sure. So in the past, we worked with a lot of different manufacturers with a lot of different battery solutions, flow batteries, redox batteries. Just remember, we make the inverter. All we need is DC. And so if you've got DC, potentially you've got a grid scale inverter system. Again, we've worked with a variety of different manufacturers, and we want to work with more in the future.
Are flow batteries dead?
I don't think so, no.
Do you see anybody doing them right now? Or
we do see some flow battery technology still in development, and we're optimistic. We'd like to see as many competitors to lithium ion as possible. So we don't want to count anyone out. We don't know what's going on in their R&D departments, but we're here to support any of our customers whenever we can with inverters.
how about sodium ion? I've talked to some people recently that are doing that.
Now, sodium possibly could be the next thing, but we'll see. You're cautiously optimistic. We'll see how things go, but we're keeping our eyes on sodium as well.
Mm-hmm. And then like anybody doing like supercapacitors or anything like that?
Yes, we've done supercapacitors in the past as well. Not generally as power dense as the lithium ion, but it has its advantages depending on the system and what the customer's requirements are.
Mm-hmm. Yep, and it's like you can't wear them out. It's not like you have some chemical soup in there like with batteries. Lead acid, is anybody's doing lead acid? Probably not. Or
I just talked to a customer yesterday that ordered some lead acid batteries from China, and he was looking to switch over to lithium, but to say that everybody's going lithium right now, that would be a misstatement because lead acid still has a place in the market.
Mm-hmm. And then flywheels, it's probably not so DC, it's more like AC, I guess. So you're probably not seeing flywheels at all.
No, we don't see much flywheel DC power, but be happy to work with anyone that has a solution.
And I shouldn't say they're not DC. So like a lot of times with the flywheel, it's going super fast. And so it's like, super high frequency alternating current. And then it goes to DC and then they change it to like, a normal type of alternating current, like you were saying, like 480 or something like that. Are people going to go to higher voltage, you think?
I do think so. I think they're going to go to higher voltage. Right now, we're at about 1,500 volts or so, but we do see those voltages going higher in the future because it's going to yield to an increased power density in the inverter and the battery system.
And when we're talking about 1,500 volts, you're talking about the AC?
The DC.
The DC, okay.
Yes.
So what's the DC voltage? Is that what you were talking about
Yeah, I'm
before?
talking about DC voltage, 1500 volts DC.
So when you were talking about 400, 480, and 600, you're talking about
AC
DC.
side.
No, that's AC.
Yeah, that's the AC
Okay,
side.
okay.
The DC side is going to be up to about 1500 volts. So generally between 720 volts DC up to about 1500 volts or so. But we do see that voltage potentially going higher in the future. And so we're looking out for that as well.
So what's like the input range of your inverter for the voltage like that works?
Yep, so about 720 volts DC up to about 1500 volts DC is our optimal range of DC power. But our inverters will continue to work, scale down in power and down to around 200 volts or so. So they're very flexible, very capable, and very reliable, with a lot of different battery conditions.
And I guess you're working with all different types of cells. So you got the cylindrical, the pouch, the prismatic. What are you seeing mostly? Let me just say, I don't know, prismatic. What are you seeing more?
Well, we generally don't get into the battery engineering part of it.
You're agnostic. You don't want to make any enemies.
Well, I mean, it's a lot. That's battery manufacturing is extremely involved, and there's a lot that goes into it. But our partners, they are extremely capable, and we have some of the best battery partners in the world when it comes to optimizing and finding appropriate solutions for energy storage systems. And so we're very happy with the support that we've received. And, I can't say that one form factor is going to be better than another. It just kind of depends on the way they're applied. And
I don't have a favorite either, like it's sort of like you take a pouch battery, you roll it up a certain way, it's a cylindrical battery, you roll it up a different way, it's a prismatic battery.
That's right. Yes. Yes.
And are you seeing like different sizes, like the battery cells? It's interesting to me now that they have battery cells that are over a kilowatt hour.
I know it. That is so neat, isn't it? Yes. So we do see that, larger and larger cell capacity, which lends to larger and larger module and then overall rack and then container size, container density. So we do see that scaling up in terms of cell capacity. Don't see it stopping anytime soon.
Yep, great, yeah. And so you said like sometimes there's the inverter and the battery and they're in separate containers. I said, is that very common? I guess like a benefit of that too is like the container that has the battery, that's got to have all the safety stuff in it.
That's right.
And then when you got all the inverters in a container, it's just like
cooling.
Yeah, cooling systems. It's not like you're in a big, huge danger for something to catch fire or anything like that.
That is correct, yes.
So that makes your life easier because you're an inverter company. So if you have a container that doesn't have batteries in it, it's like...
That's just literally what we do is that central string inverter system, and then we'll compare it to the DC, the battery box that we're using. And we've done a variety of those systems as well, and we're actually working on a new design for both of our new inverters. Just stay tuned. You'll see some things that you'll be very interested in next year.
We'll have to talk again.
Yes,
right?
please.
All right, great. Yeah. I'm going to get a whole bunch of these batteries for my house.
Wow.
Yeah, and then I'll have long duration storage, and I'll just get like, a couple hundred megawatt hours from my house, and I'll just charge it up once a year and have a whole year's worth of electricity.
Sounds like a fun project. Let's do it.
Yeah, I guess that would be kind of crazy. Like, what's the average house is using about 10,000 kilowatt hours per year. So that would 10,000 kilowatt hours, 10 megawatt hours.
Yeah.
So that's all I need is a 10 megawatt hour battery, but then I don't want to maybe charge it all the way or make it go. So I'll have to like oversize it a little bit.
Can you fit 2 Samsung battery boxes in your backyard?
Oh yeah, I got a big backyard.
We're golden then. We'll do it.
All right. I'll see you at my house. I'll give you the address and we'll go there and we'll set it up and we'll become great friends too while we're doing all that.
I look forward to it. Sounds like a plan.
All right, Michael Wise.
Yes.
And Michael Wise is the Commercial Operations Manager for LS Energy Solutions. And he just taught me a whole lot, and we're going to put a whole bunch of batteries over at my house in my really big backyard.
Let's do it.
All right. Thanks a lot, Michael.
Thank you so much.
All right.